Welcome everyone. Welcome to the next episode of Across the Opti-Verse. As we've said before, we couldn't find a South African podcast with enough tech and innovation, so we created our own. You're going to notice here that it's not Audrey, it's Kirsten. If you haven't already watched the first episode, Transforming the Medical Industry with AI and Image Analysis, she was our first guest. She's now come through as our guest interviewer for a really, really cool episode. Last week, I was approached by like 7 different people. Like, we need to talk. Kirsten needs to talk to our one of our directors and our founders, Dean Redelinghuys, about this. It's a great episode. So I said, yes, let's get it in. So we're now here recording. And I'll let Kirsten just introduce herself, talk a little bit about herself, and then we get into the interview. So Kirsten, over to you.
Hi, I'm super excited to be the host today. And for those of you who don't know me, I'm Kirsten. I'm a biomedical engineer, electrical engineer, a wife, a mom of 2 small children, a mediocre painter, a builder, a poor circuit builder, all sorts of things. And today what's exciting for me is that we're going to be talking about magical models for real results.
So without further ado, we're going to jump right into it. Just remember, you can find us wherever you get your podcasts. We would love your feedback and anything else, but let me stop talking and let the pros get into it.
Hi, I'm Kirsten, and today I'm the guest interviewer, and I'm going to be interviewing Dean, which is interesting because Dean was in my first interview. So this is pretty cool, and we're going to.
It was a long time ago.
It was a really long time ago.
Yeah.
And we're going to talk today about some stuff that I think is really interesting. Personally, I'm super excited about innovation, technology in South Africa, and how we can leverage what we've already built to go further, faster, into the future. So maybe you can tell us a little bit about yourself. What do you want to share with us?
Sure, Kirsten.
From your journey?
I guess my journey's been a strange one in the sense that I never imagined seeing myself in this position 30 years ago when we started the business. I come out of an engineering background, but really I've been a software engineer all of my life. Even before I was at university, I was writing code for all manner of people, doing all manner of things. And I guess I've taken that passion together with my engineering, and I was introduced to MathWorks products at a very early age in my university career, loved the idea, and when the opportunity came to represent MathWorks in South Africa, the business was started, so Opti-Num Solutions was started out of that. And I've pretty much been involved with the organization ever since then. Of course, we've evolved from being a simple product sales house into an organization that's working much more closely with our clients these days than we used to, and helping them solve business problems using models, analytics, and simulation.
Amazing. Thank you. And tell us a little bit about, what do you care about?
So that changes from time to time. But right now, I think the thing that drives me most is ensuring that architectures are correct. What does that mean? I think that in our environment, we tend to be considered to be data analysts who build models. But we're also people who take those models and operationalize them. And we take those operational models and we ensure that they actually deliver value to the business. And that whole pathway, I think, is a very complex environment, and it's something that over the 30 years that I've been doing this, I've realized is not an easy task, but is very rewarding when you get it right. And so that's what drives me, is making sure that all of these parts get fit together correctly and work together to solve what is fundamentally a business problem.
I really like that, especially because it speaks to me about, I love the maths and I love the research ideas that are out there in terms of statistics, machine learning models, control algorithms. But what I really, really care about too is about getting them into production, into these raw, messy environments where real life kind of is at the furnace face, and taking this kind of these abstract mathematical ideas and moving them into real life.
Yeah, and I think that's where you and I interact so much is in trying to take what we've done and create a solution that we can then leverage with other people. But for me, it goes beyond that, Kirsten. I think that for me, there's an art to making sure that the models that we build, first of all, actually can solve a business problem. And as you say, are not just the really cool maths, because the maths is cool.
Yeah.
And the AI trend that we're seeing today, for me, is interesting from the perspective that it's becoming so ubiquitous, but it's something that's actually quite old. We've been doing AI for many, many, many years, for decades, in fact. We just didn't call it AI. We called it other things. We called it neural networks. We called it log regression models. But at its heart, it's computers solving a complex mathematical problem. And it's our job to take those complex mathematical problems and make sure that they're still business related. And that, I think, is where the art of the architecture, not only of the environment that you run these models in, but the environment that they're applied in, is so important for me. And so, we've had clients who've worked with us for many years to make that a reality. And we've watched those models as they've worked throughout those environments, and how they've been applied. And we have a lot of experience at Opti-Num Solutions in being able to make sure that those models, both in operation and in use, continue to solve business problems. And I think that that's a challenge that's not easy to address. And that's what excites me. Those are the things that keep me coming back to work.
I love that. Yeah, so, I think a few weeks ago, you and I have been chatting about one particular problem that we've been helping to serve and build solutions for over the years, and it's around the industry in mining, industrial communications, making models operational, as we've been talking about now. I think thinking about the business challenges, what I've encountered in terms of my work, in terms of the clients I've worked with and the products we've been building, is, often the design and deployment of models is really challenging in the face of churn. There's people that are moving constantly. The skills and technologies change and adapt and fluctuate really often. And there's just so much uncertainty. And given the nature of software, it's really dynamic, it's easy to move, but it actually can mean that we progress slower in the face of all these kinds of options and flexibility. So, I mentioned this mining company we've been working with and some of their challenges that they were facing. Maybe you can tell us a little bit more about, what were they about and what did we do to help them? What were their challenges and kind of how did we help them?
That's actually a great example, a concrete example of the sort of things that I've been talking about up to now. So if you imagine a mining operation, there's a lot of sensors all over the mine, and in many cases, those sensors are either redundant, or they, in order for them to make sense to operations, you actually need to, in some way, combine the values of all of those sensors. So, for instance, you may develop something called a soft sensor, and a soft sensor is basically a mathematical model that takes other inputs and outputs a value. Example, you've got 6 streams coming into a tank. The sum of all of the streams is the flow into the tank. That's a very, very simple example. But you can imagine that this is a problem that could apply across the board. And when those models become a little bit more complex than the data historians can handle, you need to lean on mathematical modeling. And then you typically give that to a process engineer or a metallurgist or a data analyst to go and build that soft sensor for you. So this particular company had many instances where they had projects where a particular type of sensor needed or model needed to be built. And so, like any other organization, they would hand that over to a team. That team sometimes consisted of one person, sometimes consisted of multiple, but that team would then go and implement this model and deploy this model in whatever language they chose, however they knew how to deploy these things. And so over time, this company landed up with a lot of models that they then needed to manage. And you've already mentioned it, people leave, priorities change, focuses change. And so what they landed up with was a set of lots and lots of models, which then needed to be managed and executed in a framework that made it possible for these things to run 24/7, 365 days a year. And when the results of these models fell over, weren't correct because sensors stopped working, because people switched off switches somewhere on the plant, that someone got alerted. And so that was our journey, was to help this organization to take all of these models and kind of corral them into this environment that worked both within their operations, but also made it easy for them to monitor these models, to ensure that they were executed in the right order, and to eventually be able to scale them out to all of their plants. And so that journey that we've taken with that client led us to build what we called a continuous calculation engine. And the continuous calculation engine had a few very, very specific requirements, and some of them were fairly easy to implement, but many of them resulted in some fairly interesting challenges that we had to solve along the way. Among them is being sure that for the operators and for the people who are running these plants, all of these alerts and all of this data was actually being presented to them in a very familiar way. You can imagine that if I'm running a model and I write all my data out to a SQL database, and then someone's got to go and find that SQL database and interrogate that and figure out what's going on, that's going to make it a lot harder for that model to be used. But if it's in a familiar environment, if it's in their historian already, then it means that that model gets adopted and gets accepted a lot more easily than if it were in some other bespoke system. So that was really our focus around that. And I'm very happy to say that we managed to address those challenges. And along the way, I think we learned a lot of lessons. We learned about scale. We learned about the challenges of being able to integrate other people's code into this environment. And we also learned some fun stuff about how to build these things. And we've had quite a long journey to get to where we are today, but I'm very confident in the solution that we've provided.
That's fascinating. So you talked about calculations or algorithms on data points or sensors. How many are we talking about when you say lots and lots?
Thousands.
Yeah.
In this particular case, a mining operation, it's not just the mine, it's also the processing that happens downstream of that, can have many, many, many units, operating units on it, and each one of those has got many, many sensors. And so we're talking about thousands of sensors here, and consequently, we landed up with thousands of calculations as well that had to be managed, that had to be executed on time. Some of them were executing very quickly, some of them are executing slightly more slowly. But I think the exciting thing for us, and it's both for the client and for Opti-Num, is that this now means that they've got a consistent way of being able to bring new ideas into operation very, very quickly, very consistently. And it enables for those new ideas to be realized a lot quicker than we've been able to do, or than they've been able to do in the past. We've had an example of that where we helped them build an AI, a machine learning model, and we managed to deploy that model very, very quickly relative to the time that it would have taken otherwise.
That's fascinating. I liked what you said about, using the environment that, the process engineers or the metallurgists were already comfortable as like an end user. And that's something that I've learned along the way as well, in terms of when you're developing high quality products, it can be so frustrating when the technology or the product's not adopted. And so by kind of leaning into what are kind of your end users' comfort zone in terms of how they're going to absorb this information is really powerful. But I think also what's fascinating about this solution is that it also leans into allowing the model builders to build models in all kinds of different languages and platforms. Maybe you can speak to us a bit about that.
Thanks. It reminded me of one of the requirements that was given to us right at the beginning of the project. I think that in this particular instance, if you imagine that you have metallurgists and process engineers who may not be familiar with all of the infrastructure that goes into all of those sensors and the recording of the data of all of those sensors. So a few of the things that we were tasked to do was firstly to ensure that this environment can serve any programming language that anybody decides to build a model in. And so we've got models in R, we've got models in Python, we've got models in MATLAB, and we've got models in .NET, all running together somehow through this infrastructure, executing seamlessly and in parallel, so that we land up with the right timing requirements. And so now it's not a case of a metallurgist having to learn R or Python. If they've written something in a language that they're familiar with, they can actually go and implement that in whatever language they like, and then we just incorporate it into this continuous calculation engine environment through a small build process that we have.
It's incredible.
But it doesn't stop there. So one of the other things that we realized is that being able to get at the data was also a challenge, because sometimes it can be quite complex to, for instance, get 60-second data for the last 3 days. And so one of the things that we ensured was that responsibility lies with the continuous calculation engine and not with the designer of that model. So for someone who's building a model, all they need to worry about is the fact that they get a stream of data in or an array of data in. They have to do something to it and produce an output value and a time at which that output value is produced. So we've abstracted out all of the output requirements or the data requirements from the actual building of the model. That was a lot harder than we thought, but we believe that it's going to give the organization the ability to perhaps have a little bit more freedom in building their models. And that was one of the objectives that they came to us with. So we believe that this is one way of solving that challenge. And having said that, one of the things that I've realized through many of the engagements that we have is that building a model can't happen in isolation. You can't build a model purely focusing on the mathematics. You can't build a model focusing purely on the data, the requirements of that model. You have to think of the model as living inside of a much bigger ecosystem. And this bigger ecosystem we were exposed to through this project. So what am I talking about? There's model building, there's model deployment, being able to actually deliver the model into the environment in which it's running. But then there's also model usage.
Mm.
And this example of the CCE engine that we built actually stressed all of those things. Being able to build the models in a way that enabled them to run inside this infrastructure was an important part of that learning process. Being able to execute those models in an environment in which the models could run 24/7, 365 days a year. That for us was a key requirement, and one that we managed to solve through both our own environment and the infrastructure that it's running under. But then the usage was also an important part of that, and that was one of the reasons why we've actually integrated directly with the data historian, because without doing that, the usage would be much, much more difficult to expand to other plants, to other parts of their operations. And so as a model builder, I really stress, it's important as a model builder to understand all of those things and not just the maths, not just focus on, is this mathematically correct? It may be, but if it doesn't serve the business purpose, the model might as well not exist.
Yeah. The model purpose really matters. Yeah. I mean, I think that was going to draw me to, something that Grant often says, and Grant is your business partner, and Grant is my boss, and Grant is one of the owners. But he often says to me, so what? Like, so what? Who cares? Why, what does this mean for everyone that we're kind of sharing this with, in terms of what could they take away from this? Yeah.
So yes, the so what for me is always, I always think of these things in terms of a triangle. There's the model, and then there's the architecture in which, or the operations in which that model is going to be run, and then there's the business use. And as long as you're focusing on all three of those parts of the problem, you're going to get a much better solution than if one of them is expanded. Then you land up with a problem in either model adoption, model usage, or at the end of the day, model applicability. And those three things, the model, the operational execution of that model, and then the business use of the results of that, for me, are always the things that should drive every decision that you make in the entire project, whether it's building the model, getting that model into operations, using the model, and ultimately making sure that that model's applicable for use throughout its lifespan. And I think that, model ops, the whole idea around model operations, really has evolved out of those three things being very important in a business. And one of the great things is that, that's a big problem. You need experts who can build models. You need experts who can operationalize those models. And then you need experts who can make sure that those two people are actually applying all of that to a business case. And I'm so grateful that we have a team around us within Opti-Num Solutions who can focus on those different parts. I'm one of these big picture thinkers, and so people will come to me and say, hey, Dean, we've got a problem here, and I'll just think of the big picture, and I'll go, we can solve it like this, and here's some models that we need to build, here's how we can operationalize them, here's the business case. But I've got such a strong team consisting of people who are experts at being able to do parts of that model. So really, my role as head of product architecture is to kind of collate all of that and make sure that all of that is operating together so that that triangle doesn't get out of whack.
It's really cool, and I think I also really value our team and the support that we're able to draw on from them. I think for me, so one of the things that you've been talking about is really like the process, the design and deployment process, and the people that make that happen, and who we're building it for. And really that it's not about the languages or the tools or the platforms, but it's how we use them to move forward, which is really important. I spend often a lot of my time thinking about, like, what are the real skills that we need to help enable people with to be able to do that well. And it's not about a language, it's about a kind of way of thinking, like design thinking, critical thinking, systems thinking, the kind of end-to-end big picture thinking, and then being able to pull that down to detail, which is really tough, really, really tough. And I think one of the things that makes our people so special, each and every one of them is like a unicorn, because they're able to do that.
Yeah. You mentioned another triangle.
Yeah.
Design thinking, critical thinking, systems thinking. For me, those three things, when they work in harmony, when they work together, give us fantastic solutions, give us fantastic outcomes from any problem-solving process. And being able to put all of that in a room, being able to put all of that energy into one project, I think is a skill in and of itself. But at the end of the day, it produces great models which are able to run in operations and serve a business case. So it's those three things that I think often get missed when you look at a problem and you go, well, here's the design for this, fantastic, that's cool, but how are we actually going to get that design into production? How are we going to turn that production into useful information that the business can actually take actions on? And you're right, all three of those things are critical parts of being able to innovate in any space.
So there's been a lot of golden nuggets in this conversation, pearls of wisdom. Maybe just to ask you, is there any parting thought or comment you want to leave with us today?
If it's one thing, it's that problem solving can't be isolated to just looking at one part of that whole ecosystem that is a model's journey. You do need skills, you do need expertise in building the model, but you also need that expertise in operationalizing that model. You need expertise in being able to ensure that once that model is running in operation, that it's useful to the business. And then, of course, at some point, you're going to need to go around that circle again. We have great people who can do those things, and we're always ready to help our customers to achieve that, to go on that journey with us, to achieve that fantastic solution of a model that's in operation and serving a business need.
Thank you. Thank you. Yeah. And for me, I think this is a journey, and it's a journey of constantly learning and adapting to changing environments, circumstances. And so I know this doesn't end here. It's not like it's finished and it's like wrapped up with a bow on top. It lives on, and it changes, and it transforms, mutates into another creature. And I think that's part of the magic of building something, of making something. And so, yeah, we would love to hear from you. If you guys have interesting challenges or questions, we'd love to engage with you, around all the things we've been talking about today. And yeah, thank you for giving us your time. You can catch our podcasts wherever you get your podcasts.